Cloud Security Weaknesses, Misunderstandings, and Mitigations. Now, you've got a real treat for you here. There are 4 speakers for this session, all SANS instructors, all cloud security experts with different areas of specialization on multi-cloud, forensics, offensive operations, and continuous compliance. I think it's probably, I think the only session that I've seen that had such a large number of SANS instructors presenting all at once. So without further ado, let's please welcome Brandon, Pierre, Aaron, and AJ.
Thanks a lot, Frank. Always appreciate the intros and making me sound, and I know our other panelists sound a lot more cooler than we probably are, but I really appreciate it and super excited for this session here. We have a great topic here that we're going to talk about, the top 3 cloud security weaknesses, misunderstandings, and we're not going to just point out the problem. We're going to talk about mitigations and how we can actually get through this stuff. We have some really talented people here that you're going to learn from today. So let's go ahead and go to the next slide here. I'll do a quick introduction of myself. My name is AJ Yan. I am the founder and CEO of BiteCheck, a cybersecurity compliance automation company, also a SANS instructor for SEC 557, the Cloud Enterprise and Cloud Compliance course here at the SANS Institute. I'll turn it over to Brandon to introduce yourself, and then over to Aaron, and then we'll get right into it.
Yep. So hi, my name is Brandon Evans. I am a certified instructor with the SANS Institute. I have been developing cloud-based applications for a long time and transitioned into security, thanks in part due to all of the great classes I took with SANS. But I'm a developer by trade, and I've learned how to make secure applications. And through that process, I've learned a lot of mistakes that people make in the cloud. So I'm really excited to share that with you. And also, I think we're playing tug of war with the slides here. I have control over. I'm going to stay on this slide. Pierre Ledome unfortunately could not make it today, so I will be presenting his part on cloud forensics. But I hope he gets well, and he put a lot of great work into both these slides and the upcoming paper. So I hope you'll take the opportunity to look at those.
All right, I'm Aaron Cure. I work for Cypress Data Defense, and I used to be a developer, but what I learned is it's a lot more fun on the red team because I don't have to fix anything. So I teach SEC 588, which is cloud security, and then SEC 542, which is web app pen testing. So I get to beat stuff up and then deliver a report and walk away. So I am happy to be here. We're going to have a great presentation, and I will return it back to you, AJ.
Thanks a lot, Aaron and Brandon. Appreciate the intros. And Brandon, thanks for mentioning Pierre. We all hope he gets better and really appreciate all the work that he put in to get us here. But let's go ahead and move right into the agenda here. We have 3 big weaknesses we're going to talk about. And I love that we're starting with network visibility, because in the cloud, I think the network gets overlooked sometimes, and everybody kind of thinks it's just going to magically work. But there is a lot of stuff that's going on there that we're going to talk about that you can have some issues. We're going to get into some reckless adoption of third-party code, and there's some interesting statistics that you're going to hear about that you may not be aware of as we talk about that, and then finish up with cross-provider deployment issues. As we see more and more companies moving in and using multiple clouds, we got to talk about how you handle that at scale. But let's go ahead and get into network visibility, something that I think is a blind spot in most areas. I'll turn it over to our first speaker to hop into this.
Excellent. So again, I'm here in for Pierre, and I hope I'll do his work justice. But I have a little bit of experience with network visibility challenges because in SEC 510, public cloud security, AWS, Azure, and GCP, we share a very terrifying fact, which is by default, flow logs are not enabled on any of the big 3 cloud providers. You have to turn on those flow logs in order to be able to look at them. So what exactly is a flow log? It contains metadata about the network traffic in your virtual private cloud or virtual network. This includes IP addresses, ports, the protocols, how big the packets are, some metadata, but not the actual data. Now, why are we not capturing the actual data using flow logs? Well, the main reason, in my view, is because of the horrible compliance issue that storing the actual packets implies. Think about all of the data that is stored within your, or travels through your cloud, and as well as is stored within your cloud. We're talking about credit card numbers, social security numbers, all sorts of stuff that we do not necessarily want to persist in a logging system that a lot of people have access to. Now, you do have an option when it comes to looking at the actual contents of the traffic, and that's called traffic or packet mirroring. And I'll talk a little bit about that in the conclusion, but right now our focus is going to be on how we can use flow logs, metadata about what is in our traffic. And we'll talk about how there's a lot of differences about how these things work throughout the different cloud providers. So let's start by talking about AWS. They have really good flow logs. They can be configured at the individual machine level or the subnet or in the entire network. You can aggregate those logs very quickly, either at 1 minute or 10 minutes. And there's a lot of fields that you can capture beyond just the ones that we listed on the previous slide. They have a lot of metadata in there. But AWS is not the only solution out there. We're obviously going to talk about Azure and GCP and how they differ. One thing that's cool about AWS is you can use CloudWatch to analyze these flow logs. So if you're already familiar with using CloudWatch for, let's say, application logs or CloudTrail API logs, you can use the same interface to look at your flow logs, as well as several other capabilities. Now on to Azure. Azure has similar capabilities. One thing that I have personally noticed in my experience is that it can take quite some time for an Azure flow log to go from the flow logging system to a log analytics workspace. Now, Azure flow logs get aggregated every minute to, let's say, an Azure storage container. However, you're probably not going to want to look at these logs directly in the container, just like you wouldn't want to look at these logs directly in an S3 bucket. You'd have to transfer those logs to what's called a log analytics workspace. And I have found that that takes quite some time, but it is still quite usable and quite good. Now, Google also is very powerful when it comes to looking at your internal traffic, but there are some caveats that you need to be aware of when it comes to Google Cloud. Firstly, is that they will not capture all of your traffic. By design, it will capture, I believe, at most 1 out of every 10 packets. Regardless of what your sampling rate is, at most, it will take in 1 out of every 10 packets. So if you want to ensure that all of your traffic is captured, you would need to use an alternative mechanism like packet mirroring, which is their version of traffic mirroring in Google Cloud. Another thing that you really need to be aware of when it comes to Google Cloud flow logs is that when you start looking at them, you'll notice that unlike in AWS, unlike in Azure, there will be no indication of whether or not the traffic was accepted or rejected. And you might say, that sounds like a bug, right? We should know whether or not the traffic we're looking at was accepted or rejected. This must be a mistake. But by design, that is not the case. By design, Google Cloud VPC flow logs are captured at the virtual machine level behind the firewall. What does that mean? It means that if traffic is sent ingress and is blocked by the firewall, you will not see a corresponding VPC flow log. Meanwhile, all of your traffic egress, regardless of whether or not it is blocked, you will see in the flow logs. So we're basically missing a big part of the picture when we just use VPC flow logs. Alternatively, we can also use firewall rules logging. And what firewall rules logging does is it allows you to test whether or not your firewall rules are actually working, see when traffic is blocked and when it is not blocked. So in order to get the full picture, you have to have both VPC flow logs and firewall rules logging enabled. A lot of people make that mistake and only enable one of them. But just like with Azure and AWS, we have multiple ways of analyzing the logs. And in conclusion, Cloud flow logs are powerful, but they're only powerful if you have them enabled, and they're only powerful if you're actually looking at them. So do not just say, okay, cloud has flow logs, therefore I don't need to worry about this control. A, you're capturing nothing by default, and B, if no one looks at the log, does it really matter? If a log is unattended in the woods, does it really make alert? Who knows? I would say no. I would say no, it's useless at that point. And alternatively, you have some other tools you can use to look at your traffic. The one I flagged before was traffic or packet mirroring, which actually allows you to copy traffic from one virtual machine to another. And that second virtual machine can be running your traditional intrusion detection or intrusion prevention software. And that's going to bring me to the second topic I want to talk to you about today, which is reckless adoption of third-party code. Now, AJ referred to this statistic earlier, and he wanted to tease that out, and it's still unbelievable when you look at it. On average, only 10% of code is created in-house by the organization that is using that code. I know as a developer that this is very true. It has changed a lot since I started developing with PHP about 15 years ago. Nowadays, you are bringing in all of these packages from all of these different repositories, especially when it comes to the Node.js ecosystem. I've never seen anything quite like it, as you'll see on the next slide. But even if you do not use JavaScript, which you do, by the way, you absolutely do, even if you don't use JavaScript, there are other different repositories and ecosystems that you need to look at. For now, PHP also has one. You have Java with Maven, NuGet for C#, and the list goes on and on. We can even think about things like our image repositories for our containers or our Chef code that's used for configuration management. All of these are a form of supply chain. And we're all aware of supply chain attacks like the one that happened with SolarWinds in late 2020. And as scary as it is to have an application provided by a third party, I think it's much scarier how our internal applications use 90% code not maintained by the organization. So as a really funny example of this, for this demonstration, I created a new Node.js application, and I simply installed the most popular dependency in the Node.js ecosystem, which is the request library. So that's seemingly okay, right? I have this little application. I only have one dependency. What's the problem? Well, this one dependency has this many transitive dependencies, meaning dependencies of the request package itself, or dependencies of the request package itself. 35,000 individual packages depend on request, and request depends on 46 packages, which depends on et cetera, et cetera, et cetera. So at the end of the day, your application is using tens of thousands, if not hundreds of thousands, if not millions of packages, even if it is a small application. Now, this has resulted in a variety of different types of supply chain vulnerabilities. And I don't know if anybody else has classified these into these three different categories, especially because the last one is relatively new, but I did in this case, and I hope it's useful when you're wrapping your head around these different types of attacks. The first one is when the package itself has a vulnerability. When you have a package that unknowingly, unintentionally introduces a vulnerability. It's a legitimate package, it means well, but it is vulnerable in some way. Now, this should be triggering some flashbacks of December of 2021, where everybody was circling around the organization saying, what the heck is log4j and what do I do about it? And log4j is simply a package that contained legitimate code, but had a very serious vulnerability that was patched afterwards. But until you patched that vulnerability, you had a remote code execution flaw. So that's one type of vulnerability. What I've seen more recently is repository compromises, where a legitimate package is compromised by a third party potentially by attacking the author's account. And as a result, the attacker is able to publish a new version of that package containing malware. I have 4 examples of this in recent history. In July of 2018, that may have actually been 2019. My apologies if I'm wrong about that. There was a vulnerability in this application called ESLint. Now, ESLint, all it does is it looks at your JavaScript code, your ECMAScript code, and tells you whether or not your code is clean, whether or not it's nicely written, whether or not it has some clear, obvious flaws, like variables being used that are never referenced elsewhere. So that's all this does. But someone compromised that package and added another line of code or several lines of code that would then download code from pastebin.com and run it. So they injected malware that would run every time that you invoked ESLint. And the only version of this code that we are aware of would take the npm JS tokens on that machine, the tokens that people use to publish and download packages from the Node package manager. It would take those tokens and it would send it to an anonymous third-party URL. And I think the idea behind this compromise was, hey, we've compromised one package. Let's get all of these different tokens and use those tokens to compromise other packages, kind of like a worm. Thankfully, NPM took decisive action and they revoked all of the tokens that were generated prior to that date. This was great from the perspective of stopping this problem, but it was terrible from a developer perspective because this basically broke everything. But several years later, we're doing okay. The point of this is just to show that people can compromise this repository and replace it with arbitrary code. And then in Q4 of 2021, there were 3 other compromises. Now, I'm not going to go into a whole lot of details about those compromises. There's a lot of interesting details that are provided in the white paper that's coming in a month. But this just goes to show that you really need to protect your repositories using things like 2-factor or multi-factor authentication. And in fact, there's an ongoing petition telling npmjs.com, you should make it so that people have to 2-factor authenticate to publish new code. You cannot leave that decision up to the individual. And I agree. And then finally, my favorite, quote unquote, new type of attack is package-based protestware. This is where an author of a package, regardless of whether or not their original intentions were good, publishes malware to their repository. And there are 2 terrifying examples of this in the past year. In January of 2022, an author of 2 little packages that really didn't do that much, honestly, had inserted some malware that whenever their packages were invoked, it would crash the application. And they did this to protest all of the corporations that were using their work for free. Now, technically speaking, they were right. A lot of corporations were using their code. I don't think that's an excuse to crash applications. But the only reason that a lot of corporations were using their code was because these 2 little packages, one of them just added colors to the command line, were used by a lot of other, in my opinion, much more useful packages. And then by the transitive property, that would make it so that any other package would crash the entire application. So this was really bad, but arguably even worse was in March of 2022, the author of a very popular, honestly, very important package added some code to the package that would do a couple of things. The main thing it would do was it would do a geolocation invocation to figure out whether or not this code was being run by Russia or Belarus IP space. And if it detected that this code was running in that space, it would overwrite every single file on the file system with a single character of a heart ASCII character, effectively deleting all of those files. Now, I'm not going to get into the ethical or moral discussion around this. I think there's a lot of fun threads you could read about this if you're so inclined to, and we link to that in our paper. But all I'm going to express here is that you do not want to have these types of packages in your ecosystem. Now, how does this relate to the cloud specifically? Well, first of all, it doesn't. It applies to on-prem as well. But the main thing I'm going to focus on in this set of slides is how you could use these vulnerable or purposefully malicious packages to attack what's called the Cloud Instance Metadata Service. This is a service that runs on all of the virtual machines in each of the big three cloud providers. It contains a lot of different data about the virtual machine, but most importantly, it contains IAM credentials. It contains information or credentials that, if used by the virtual machine, will allow it to talk to other cloud services. And we're going to talk about why that's necessary in a moment, but to quickly sum up this point, this was exploited in 2019 under the Capital One breach, and this resulted in 100 million credit card applications being stolen. We'll talk a little bit more about why that is in a moment, but normally the IMDS is not interacted with manually or even by the code that you write. It's normally interacted with using the official Cloud SDK packages. So, for example, if I want my application to be able to talk to my Dynamo database, behind the scenes, the AWS Software Development Kit is going to talk to the Instance Metadata Service, and it is going to retrieve those credentials and use those credentials to talk to the Dynamo database. Your developers are not directly interfacing with the IMDS. They are using third-party code to do so on purpose. But what that means is that third-party code could theoretically be used to talk to the Instance Metadata Service maliciously. So here is a small snippet of code that you can use to retrieve the IMDS IAM credentials from the IMDS just with a small amount of JavaScript code. And this will fetch those credentials just like the official packages do. And from there, we could send those credentials to a third party. Potentially, we could stop that if we look at our flow logs, but nonetheless, this is a way that we could exfiltrate highly sensitive information. And the scariest part about this is that this attack works against the AWS IMDS v2. In response to the Capital One breach that happened in July of 2019, AWS published a new version of the IMDS that prevented a variety of different cases, and one of those cases was the case that Capital One had. So with the IMDS v2, the issue that happened with Capital One probably wouldn't have happened. But with code that is compromised like this, they can do whatever they want. How can you stop the code from talking to the Instance Metadata Service? There are a couple of solutions we'll mention, but none of them are really perfect, as you'll see shortly. And this is just one example of how a third-party package could steal credentials that matter a lot to you. So let's talk a little bit about the mitigations. Firstly, we can theoretically disable or restrict access to the IMDS in its entirety. Now, this will not work in, I would say, 99% of your cases. Why? Well, what does the IMDS do? It allows your virtual machine to talk to other cloud services by giving it credentials. Does your cloud VM talk to other cloud services? Probably. What's the point of your application if it's not going to talk to a database? If it's not going to get assets from a storage bucket, if it's not going to interact with any number of different cloud services. So unless you are interacting with no cloud services, unless you're running a completely isolated workload, you really need to use the IMDS. Your alternative is to generate long-lived credentials that live on your virtual machine or are stored in a secrets manager or sometimes even stored in code. That solution is worse than having the IMDS enabled in the first place. The IMDS, for all of its faults, has temporary credentials. If you put in long-lived credentials on your virtual machine, those are also compromisable and will last for an indefinite period of time. So do not use long-lived credentials to get around the IMDS. Do not take that away from this presentation. Also, do note that in Google Cloud, you cannot prevent access to the IMDS. There is a firewall rule that says unconditionally, you have to allow access to the IMDS. And they do this because if you blocked access to the IMDS without knowing what you're doing, you would break a lot of things. You also should use egress rules to prevent your credentials from being exfiltrated, as well as flow logs to monitor for whenever they are. Then number 3, I would say, is probably the most important one for this session. And it goes back to what we talked about earlier about how IAM is so important. Identity and access management is one of the most important skills for you to learn in the cloud. And I would say that this is one of the most important things to do to mitigate this type of issue. Because in the case of Capital One, the attacker was able to get a set of credentials, and that's bad. What's worse? Those credentials allow the attacker to download 100 million credit card applications. Why does that server have access to 100 million credit card applications? Well, we have some theories that we share in Sec 510, which I can't get into right now, but the short answer is they shouldn't have. They should not have had that amount of permission. So definitely want to lock down those permissions. You also want to follow best practices when it comes to dependency management. And I know that I've kind of overstayed my welcome, so definitely check that out in the white paper. But the one I'm going to highlight is runtime access security protection. Runtime application security protection. That's something you could use to prevent code from executing that looks at the IMDS theoretically. We all know that everybody implements RASP in production, right? Totally. There's 2 pitfalls that I really have to highlight for you though before I run out, which is 1, do not use AWS managed policies. It sounds like you should use the policies that AWS gives you. No, do not do that, because not only do they grant some unnecessary actions, the resource clause is wide open. You can perform those actions on any resource. And why do they do this? Well, AWS has no idea which bucket contains your credit card applications versus your photos. And how could they? You need to apply business logic rules for your business. So using those AWS managed policies are really problematic. And then finally, when it comes to Google Cloud, Anton talked about the shared responsibility model earlier and how inevitably it is up to the user of the cloud to do things right. And that's true, but I have to warn you that the defaults for the Google Compute Engine is incredibly overly permissive. By default, a virtual machine that you launch in Google Cloud's Compute Engine has the extremely dangerous editor role, which basically gives it read and write access to the entire project, allowing the virtual machine to launch and delete other virtual machines, just as one example. I think there's 5,000 different actions that can be performed at the project level due to this default service account. So if you take nothing away from this and you're trying to secure Google Cloud Compute, get rid of that default service account that has that really overly permissive service account set of permissions. That brings me to my conclusion. Supply chain attacks, as you know, are on the rise. Compromising one application is possible, but compromising one of the tens of thousands of packages you use are easier. Cloud IMDSs are inevitable, but they can be exploited. AWS's IMDS can be hardened, whereas the other 2 IMDSs are actually more hardened than the AWS one by default, but people can still access it via code. IMDS access can be removed, but it will break most applications. Network controls and secure package management are key. And oh my goodness, learn IAM policy, because it will decimate the impact of such a credential stealing event. And that's my section.
Amazing stuff, Brandon. Thank you so much. Just beginning with the network visibility portion and talking about flow logs. You got some people in here that want to have a deep discussion with you about flow logs in Slack, because everybody has those opinions and it's just so important. And then this is just, I think, eye-opening for folks. I love that you talked about those managed policies. They become a crutch sometimes for folks that I see out there. And that resource thing, man, you gotta be like, I just wish more and more people knew that. So thank you so much for bringing that up. Let's go ahead and move into the final cloud security weakness here. weakness number 3 of cloud provider deployments. Aaron, I'm excited for you to share some of your knowledge and expertise here on this topic.
You calling me the next weakness, AJ? Wow, that hurts. Yeah, so I know nobody in this call is doing this, right? But apparently there are people out there who have deployments in multiple cloud environments. I know it's crazy. We all just pick one and stick with it, and that's just the way the world works, right? But so in reality, we're all everywhere. And what started off pretty simply is you'd pick an environment, you'd stay with it, and everything worked. Now we live in AWS, we live in Azure, we live in Google Cloud, we live in Oracle Cloud, we live in Gov Cloud, we live in all the different places, right, across all of the worlds. And there are a lot of differences and a lot of different things that go by the same name, that they have completely different functions, and really a lack of training for all of us on how to differentiate those and move across them. So I'm going to talk about a couple of them today that just as an example that really can catch us if we're not watching and get us in a lot of trouble. So on the next slide here, I'm going to talk a little bit about functions. And we have a lot of, just FYI, I don't have access to the slides, guys, so you're going to have to take my cues. There we go.
Next one.
Perfect. That's the one. So functions, right? We use them all the time. They're basically little chunks of code that we can run serverless in any of the environments and allow different virtual machines to call them, allow websites to call them, just give us this universal functionality. A lot of times we implement microservices and things like that in these service types. Well, AWS has one, and it's called the Lambda function, right? We've used them a lot. They can't be called outside of the AWS environment directly. They're only accessible by internal objects. So if you create a Lambda function, you can call it from an EC2 instance. You can directly call that. That works. You can call it from the AWS command line interface, the CLI. But if you want to call it from a website, you want to be able to call it from an HTTPS post, then you have to add additional functionality. So it's a little more closed down than some of the other environments. And to get it exposed like that, we have to use an API gateway. And that API gateway allows us to create and publish interfaces and ways to access that code. We have to tell it what parameters come in what places in the request and how it gets pushed into the Lambda function and how the results are handled. So there's a whole thought process around creating those functions and exposing them to the world. Now, if we look at Azure next, Azure, when you create a function, by default, it assigns it a public IP. It's ready to go. It's publicly accessible, and you can hit it directly on that port or what's inside the app that's exposed a collection of functions. A little confusion here. Azure actually has an API gateway also. Okay, well, as an AWS guy, I'm going to come over here. I'm going to configure an API gateway. Wait, these look different. The options are different. The settings are different. Oh, yeah, that's because it's a load balancer. It's not a control for functions. It's literally a way to load balance applications. If we go to Google, it has an API gateway and it functions very similar to AWS, but we don't have to have it. We can deploy it with an HTTP trigger and directly call it without any additional functionality. So if I come across into this environment and assume that the things I know from the other environment exist, there's a huge potential right away for us to either overexpose or allow too much control of our various functions. And then we've talked several times about permissions. right? And we're going to hear it over and over and over because every environment has similar capabilities, but they do it differently. AWS, in my opinion, is the most complex, the most interesting to understand, because there are a lot of different ways that have evolved over time to control those accounts. So you started off with the account root user, and that's the base level user that you signed up for AWS with. That is a very powerful user. You can't deny access in it from AWN or IAM, and you can't restrict its access to any services. That's a very powerful account, and a lot of people are still using that as their default day-to-day daily driver account. You also have the ability to grant access to objects in multiple accounts, so you can share those things across, and we can create permissions policies that will allow users or services or various actions to happen on all of these things, S3 buckets, EC2 instances, all of these various things. We can create policies, and then we can create things like permission boundaries to stop those policies from being in effect. So now we have policies that we think are being applied and other policies that are applied directly on the resource, and it can get overwhelming. In fact, on the next slide, you can just see kind of how that breaks out. So on the left over here, we have a user, and the user has the ability to read from an S3 bucket called sample bucket. Over on sample bucket, sample user is allowed to list and read. And another user has everything allowed, and a third user has the ability to list. But now we have a permissions boundary down here that says deny everything to the sample bucket. And then we have a version policy. Now, which one of these applies? And at what point do we say this one is valid, this one is valid? So you can see it gets a little complex, or very complex, really quickly. Azure is a little more straightforward. It uses the Active Directory model, and it has predefined roles. You can also create new ones. Some of the predefined roles are pretty permissive. So again, following that policy of least privilege, we need to take that and crank them down a little bit, just pick out the things that we actually need. But we can also assign roles separately between users and non-interactive users, or service principals, right? Accounts that run for applications or services and things like that. Google, we just talked a few minutes ago about the editor role, right? The ability to create and spawn things. You also have the owner view and the viewer roles, right? It has a basic IAM system that you can have both interactive and non-interactive or service accounts also, but you have to set the individual roles and permissions. So you have to make sure that you're correctly assigning all of those things. So basically, securing the cloud is hard, right? Knowing what the various pieces are and the moving pieces in each of these environments gives us a very big task and a huge body of knowledge that we have to absorb. When you start moving into multi-cloud, or you start talking between the cloud, you're sending data between services and passing roles and all of that kind of stuff. There's a lot to keep track of. And there are similarities and differences in each of these. Everyone has the ability to create a virtual machine, but they all call them different things. As an attacker, I'm going to find a way to get in. So I'm going to exploit these overprivileged accounts, these functions that we didn't know that were actually running with public IPs, and figure out whatever I can do. And oh yeah, don't forget, because you probably have a VPN between your cloud environment and your on-prem network. So as soon as I can get into the cloud, I can go on-prem and back. But we won't talk about that. So basically, we need to stay abreast of the latest threats and defenses. Let's know what's out there. Let's see what things are available. Let's know, and then test, test, test. You should be running constant scans and pen tests of your environments. Know what's out there. You should be pushing things through infrastructure as code, and you should be scanning that infrastructure as code and know what's being built, scanning the environment, make sure it links back to that, all of those things. So it's fun. Have a good time. AJ.
Thanks so much, Aaron. Excuse me. That was amazing. I appreciate the detailed discussion there. And Brandon, like you mentioned earlier, we talked about shared responsibility model. All of these weaknesses are the things that are on you. This is not going to be the cloud provider. They're not going to. They created those managed policies that we're talking about. They created a lot of these things. It's on you to secure them. So I hope everyone took away from this. Multi-cloud environments. It's going to be tough to secure those. It's a challenging thing. Supply chain attacks are on the rise, so we really have to understand what's in our supply chain. And then lastly, we have to have that visibility on our network. So important, so important. And thank you, Brandon. Thank you, Aaron, for sharing your knowledge and expertise here with the community. I know there's a lot of great feedback in Slack right now. I see you here, Diana. I wonder if we have time to answer one of these questions here in the Q&A right before 2. Awesome. This is a question that I saw, and I was like, I want to get Brandon and Aaron's insight on here around resources that you recommend for learning best practices for IAM in the cloud. As you mentioned, IAM is just so important. It doesn't matter all of the bells and whistles you have. If you leave your front door open, it doesn't really matter. So what are some things that you all have seen that are the best way to learn IAM in the cloud? Brandon, I'll start with you.
Well, obviously, I'm very biased on this topic because I'm a SANS course author, and I wanted to share on the point of shared responsibility. Like you mentioned, the customer is responsible for securing the cloud. The cloud provider is responsible for securing the cloud services, as well as giving you the ability to secure your own data. But I think SANS, as part of the shared responsibility model, is here to teach you how to effectively do those things, because it's really easy to say, hey, customers, just do everything right. It's much more difficult than that, and you need to have some level of education to be able to implement those controls properly. So Sec 510 is the course that I teach. Public cloud security, AWS, Azure, GCP, goes over 33%, 33%, the big cloud providers, and we have an entire day on IAM. That's a 500 level course. If you're still trying to break into cloud security, you may want to take a look at Sec 488, which is more foundational, as well as if you're just brand new to the cloud and you're not even really sure what this whole cloud thing is, we also have a more foundational course, 388. In terms of free resources, I think the best thing you can do is just practice, test, like Aaron mentioned, because we can theorize about IAM policy forever. It's never going to be real until you actually set up a policy and see the impacts of those policies.
I'm going to jump in. I think Brandon covered that one perfectly, but my particular favorite question was, is there a good resource for pen testing cloud environments? And as a co-author of Sec 588, cloud pen testing, I think, yeah, there's a great resource. You should come see us and we'll teach you all the fun stuff that you need to get in and beat it up.
Yes, my bad. I forgot that they mentioned the word pen testing. Yes, there's specialization beyond just learning those fundamentals. And absolutely, that's why we have an awesome 13 set of classes now in the curriculum.
Exactly.
Right. And that's the thing. To properly pen test it, to be able to go after it, you have to understand it in the first place. So having that base knowledge, figuring out what is out there, what's supposed to be out there is huge.
Yeah, the cloud security curriculum is just so robust, and what we're doing here at SANS, I think, is going to help build the future of the security professionals that are securing the cloud because of all the different layers that you all just talked about. So thanks again, Brandon and Aaron. It's been a pleasure doing this with you all, and I'm also very excited for the next session. So Diana, I'll turn it over to you to get it started.